In this demo, we're going to look at the Microsoft Agent Framework and how you can implement RAG using the text search provider and the in-memory vector store. So this is the accompanying blog for this demo, and in the blog we dive into why RAG matters for AI agents, how it works in conjunction with the Microsoft Agent Framework, and the project structure. We detail the models and how we can build a text search store and how this effectively wraps the in-memory vector store. We detail some of the sample content, and just for your context, we're building on the IronMind AI personal trainer agent that we have been working on throughout this series. So we'll jump out of the blog and into Visual Studio, and what we'll see is we'll spin up our agent in the form of a console application, and we'll be able to issue queries against our vector database. So we're in Visual Studio, and if we look over to the right hand side here, we can see that we have a number of classes. We can open each of these up. So our text search document represents a document that can be stored and searched for in our vector store. We have our text search store. So this is our vector store, and for the purposes of this demo, it runs in memory, and we can collapse these. We've also got an internal text record type, which is used by our vector store, and that's what we can see down here. We need a helper method to get data into our vector store, which is this method getSampleDocuments, and our content is related to strength training, which is the purpose of our IronMind AI personal trainer agent. So here we can see that we have a series of documents. We set the source ID, the name, the link, and some text. We have a method to perform a search against the database, and init line 51, that's the method that's responsible for performing the search. Now, an important thing to note here is that we can see that we pass in the query as a string parameter. Well, what happens under the hood is the agent framework builds on some of the older semantic kernel SDK, in that the inbound string is converted to its vectorized counterpart, and the vectors are compared under the hood, and the closest matches are returned back to the caller. And it's the same process for upserting content into the vector store, and that's what we can see here. In our constructor, that's where we set the vector store definition. So now that we have ran through the vector store and the models that are used to manipulate it, we can have a look at our agent. So here is our IronMind AI personal trainer agent. So in our constructor, we set up the in-memory vector store, as well as defining the embeddings generator. We create our agent. So the first thing that we do is we have a method to create our agent. So one of the first things that we have to do is add content into the text store, which is our vector store. And we have to define some text search options. And this tells our agent how to behave. And the next thing that we do is we pass these parameters in to the OpenAI client, and we define some instructions. We tell our agent that it must only answer questions using data within the context. And we also tell it to cite any sources by name and include the hyperlinks at the end of the response. We then pass these parameters into the text search provider and define an in-memory chat history provider. We can see the search method for our agent simply calls our text search store method search async, and then we return the content that is found in the vector store. So with a run through of the models and our agent, we can jump into the program CS file. So because we've encapsulated the agent's behavior in vector store in discrete classes such as IronMind RAG agent and text search store, our program CS file is very simple. The first thing that we do is instantiate our agent, then we create it, and then we kick off a session. We output some information into the console, and then we run our agent. So we can run our agent now, and at which point we will be prompted to supply a query. So what's happened is our vector store has been populated with sample content, and now we can issue a query against it. So we can say, as a beginner, what can I do? We can send that over to the agent. That string is going to be vectorized automatically by the Microsoft Agent Framework and then used to perform a search against our vectorized content. So if we scroll up, we can see there's our query and our agent has replied with 6 steps, okay? It talks about compound movements, training frequency, weight and repetition, etc, etc. But more importantly, down at the bottom, we can see the citations in relation to the content that was used to generate this RAG response. So that's it. That was an overview of how you can implement RAG using the Microsoft Agent Framework. If you would like more information about how all of this hangs together, you can read the accompanying blog and see the code at jamiemaguire.net.